Understanding trigonometric ratios. C5. In a right triangle, determine the angles for which sine of an angle will be greater than cosine of that angle. Okay, let's try to understand this. So what we will do is we'll make our right triangle. That's the one. And here, let's say this is A, this is B, and that is C. And that is our right triangle. Now, let's consider angle A. So, this side is A for us, this side is B for us, this side is C. Side opposite to the vertex gets that name of the vertex, right? So, opposite to A, small a, opposite to B, small b, and then C for C. Now, the question is we need to compare what is sine and cosine, and when is sine greater than cosine. Okay, let's figure out what is sine A. So sine A is actually equals to opposite over hypotenuse. We are considering this angle A, right? So if you see from this angle, opposite side is this side. So it is A over C, right? Where C is the hypotenuse. How about the cosine of A? Cosine is adjacent over hypotenuse. So we have cos of A is equals to adjacent side is B here, so it's B over C. Now when is A bigger than B? We have same denominator. So basically, if we want to determine the angles for which sine of an angle will be greater than cosine of an angle. So for this angle A, if A is bigger, A is bigger. If A is bigger, the small a, the side opposite is also bigger, right? So basically, and B is the side opposite, angle B. So it boils down to that if angle A is bigger than angle B, if angle A is bigger than angle B, if this is bigger than B, then sine A should be greater than cos A. Is that okay? So that is probably because, see, that is how it is, because it is boils down to the ratio of the sides, correct? So sine is A over C. For sine to be bigger, A should be greater than B, right? For sine to be bigger, we want A to be bigger than B, right? Or we can see like this. We can think like this also. For sine A to be greater than cos of A, side A should be greater than side B. Does it make sense? Now, when will side A be greater than side B? Side A will be greater than side B if angle A is greater than angle B, correct? That's what it is, correct. Now, that means if the two angles are equal, then sine and cosine will be equal. Perfect. And it works, right? How? You know sine of 45, correct? So if you consider this triangle of 45 degrees, where these two sides are equal, and this side is angle is 45 degrees, right? In that case, if this is 1, this is 1, this is square root 2. So we know that sine of 45 is equals to cos of 45 degrees, correct? And both are equal to 1 over square root 2, correct? But if the angle is more than 45 degrees, then sine is greater than cosine. That's what it comes to. Therefore, we conclude that in a triangle, if angle A is greater than 45 degrees, then sine of A is greater than cosine of A. So that is our conclusion, correct? So at 45 degrees, both are same. So that's how it is. So remember this. So in any triangle, we have sine greater than cosine if the angle is 45 degrees. If you plot for different angles, you'll probably get a graph like this. You will get a graph like this. In the first 90 degrees, let's say this is 90 degrees. This is starting with 0 degrees, and this is 90 degrees. Then you'll find that the sine graph actually increases like this. to 1, and it is maximum 1 here. As far as cosine is concerned, you'll see it starts with 1, but it decreases as it goes down to 90 to 0, right? So you'll find that sine actually increases from 0 to 1 as the angle A increases from 0 to 90 degrees, right? And this point, right in the center, when both of them are equal, this is at 45 degrees, and the value here is 1 over square root 2. 1 over square root 2. So that is how it is. If here we have the angles A, let me write angle A here in degrees, and this is in units ratio, right? So unit 1. So that is how it is. So that is how sine and cosine are related in a triangle. Okay? Thank you.